Okay, so today we'll directly start with the numerical now. So take down the question. So as I've already mentioned, even in limit state method, you'll have the same type of numericals. First is to find out the MR, and the second one is to design the section. So in this, you will not have the type to actually find out the stresses. Okay, so this is not a stress-based method. So in working stress method, you used to check the permissible stresses. Since it is not a stress-based method, you'll have two types. First is to find out the moment of resistance, and the second is to design the section. Is this clear, everyone? I hope I'm audible now.
Yes, sir.
Okay, so first, I hope you have the equations with you. So now tell me the equations for XU max. Okay, equation for XU max for Fe250 we have seen, and for Fe415 and Fe500. Okay, so XU max for Fe250 is 0.53D. For Fe415 it is 0.48D, and for Fe500 it is 0.46D. Okay, and then afterwards we had seen MR of a balanced section. So MR of a singly reinforced balanced section is given by 0.148 FCK BD square. This is for Fe250, correct? And this is 0.138 FCK BD square. This is for which grade? Fe415. And then we have 0.133 FCK BD square for Fe500. Is this clear? Yes, I hope it is visible now and audible what I'm saying.
Yes, sir.
Yeah, after this we had seen MR of under reinforced section. Okay, just we are going through the equations so that it is easy when using the problems. So MR of an under reinforced section में सबसे पहले we'll find out XU. Okay. Now for finding out the value of XU, we will equate CU equal to TU. CU is nothing but 0.36 FCKB into XU is equal to 0.87 FY into AST. ठीक है, इससे तुमको XU मिल जाएगा. And then XU max तो इससे मिल जाएगा डायरेक्ट. ठीक है, so in LSM actually you have ready-made equations to find everything. ठीक है, unlike in WS. Then after this, if you find out XU max, then you'll have to check. So if XU is less than XU max, so then it is under reinforced section. Okay. And if X is greater than XU max, then it is an over reinforced section. Okay. So अगर first condition है, so if XU is less than XU max, then MR is given by, okay, then MR is given by CU into lever arm, or MR is also given by TU into lever arm. ठीक है, CU into Z क्या हो जाएगा? 0.36 FCKB into XU into D minus 0.42 XU, ठीक है, और MR is equal to TU into लीवर आर्म क्या हो जाएगा 0.87 FY into AST into D minus 0.42 XU. So these are the basic equations which you have to understand or remember before actually solving the problems. ठीक है, अगर over reinforced है, so then what we will do, if it is an over reinforced section, then we will consider it as a balanced section and then find out the MR, that is XU equal to XU max. ठीक है, while designing we never design an over reinforced section, so अगर जब design कर रहे रहेंगे तो we will redesign, and when we are finding out the MR, so in that case we will take XU equal to XU max and then find out the MR. Is this clear everyone?
फिर से बताओ ना एक बार.
Equation is visible ना? Is it visible?
हाँ सर, हाँ.
sir.
Okay. Yes, done with this everyone. Now we can start with the problem. So write down the question. Yes, everyone. Are you ready?
Yes, sir.
Okay. So write down the question. Calculate the balanced percentage of steel. Calculate the balanced percentage of steel. For M20 and Fe415. First question, M20 and Fe415. Second part, M25 and Fe415. Okay. So we have to find out balanced percentage of steel. Okay, so it is also called as the limiting percentage of steel, or you can say PT limit. Okay, limit of balanced means one and the same. So calculate the balanced percentage of steel for M20 and Fe415, M25 and Fe415, and M30 and Fe500. Okay. So we know that for a balanced section, okay, for a balanced section, we know that by equating Cu equal to Tu, what we have 0.36 FCK into B into XU max. Okay, when I'm talking about balanced means it will be XU max, and Tu is equal to 0.87 Fy into AST. Okay. So now what we will do, actually what we want PT, and PT is given by what? AST upon BD into 100. Understood? This is what we want. So now I will just try to make this form. Okay, so 0.36 FCK B into D. So I am multiplying and divide by D. XU max upon D is equal to 0.87 Fy into AST. Okay, So now if I take this BD here, so what will this become? AST upon BD. ठीक है, AST इधर, BD इधर. So what is remaining here? 0.36 FCK and XU max upon D, and this 0.87 FY. Okay. So what we want percentage. So AST upon BD. So if you multiply by 100, so you will get this. So therefore, PT percentage is equal to 0.36 FCK upon 0.87 FY into XU max by D into 100. Is this fine? So basically what we are trying to find out, the balance percentage of steel. So this is actually, we have derived the equation, how to find the balance percentage. Okay. So now you can find out easily. So now tell me, for first part, M20 and Fe415, okay, what is FCK? FCK is 20. And what is FY? FY is 415. So therefore, what we have to find out this. Okay, XU max by D. So what is XU max by D for M20 and Fe415? Okay, what is XU max for Fe415?
0.48 times of D.
0.48 D. अच्छा, मेरी वॉइस क्लियर है? Am I audible properly?
Yes,
Yes,
sir.
sir.
Okay. Yes. So ये क्या हो जाएगा? 0.48, correct? So therefore PT percentage ये निकालो अभी, 0.36, FCK कितना है? 20, and 0.87 FY कितना है? 415, into this is 0.48 into 100. Give me the value now. Write in the chat box. Yeah, 0. So 0.957 percentage. So this is the balanced percentage of steel or the PT limit for this particular grade of concrete and steel. Is this clear, everyone? So similarly, you can find out for second and 3. So second का भी बताओ मुझे quickly. Second का value बताओ. For M25 and Fe415. $1.196, correct. So for the second is 1.196%. Yes, is this clear to everyone? Okay. So now we will start with the actual problem. So this is just the basic for you to understand how to find out the balance percentage of steel. So now we will take a problem on moment of resistance. Now take down the question, all of you. Yes, so calculate the moment of resistance calculate moment of resistance for a singly reinforced rectangular section. Calculate moment of resistance for a singly reinforced rectangular section 300 by 750 mm, 300 by 750 mm, reinforced with 3 bars of 20 mm diameter, reinforced with 3 bars of 20 mm diameter, reinforced with 3 bars of 20 mm diameter, placed at an effective cover of 40 mm, placed at an effective cover of 40 mm, consider M20 and Fe415, consider M20 and Fe415, also calculate the safe UDL the beam can carry, also calculate the safe UDL the beam can carry over a simply supported span of 8 meters. Also calculate the safe UDL the beam can carry over a simply supported span of 8 meters. That is the question. Yes, all of you have noted down the question.
Yes, sir.
Okay. So start with the solution now. Basically, you have to find out the MR. Okay, so quickly solve this. We have 10 minutes left. So we will try to finish this problem before the session ends. Okay, so what is the procedure? Can anyone tell me? Basically, we are trying to find out the MR and then the safe UDL also. ठीक है, सबसे पहले क्या find out करेंगे?
Critical neutral axis. Critical neutral axis.
Okay. Then, okay, so here we will state as XU max. So first we'll find out the neutral axis, XU and then XU max, and then we will check whether it is an under reinforced or over reinforced section. So if it is an under reinforced section, then we will find out the MR by either using C into lever arm or U into lever arm, and then we will find out the UDL. So the steps remain the same. Okay, so we have already done this in WSM. Only thing is that the equations will change. Otherwise, the concept remains the same. So first, let me write down what is given here. What are the dimensions?
300 by 750 mm.
Okay, B is 300 and D is, which D is this effective depth over overall depth?
Capital D. Overall.
Okay, capital D is 750 mm, and then AST is given to us, I think 3 bars of 20 diameter. So just tell me the area. And
942.477.
942.477 and effective cover is 40 mm, and we have to use M20 and Fe415, and L is given as 8 meter span. So now what we have to find? We have to find first MR, and then second we have to find safe union. Okay. So first we will find out to find XU. Okay, calculation of XU. So first we'll find this. So before that, we will have to find out what we will have to find out the effective depth. So this is 300 and 3 bars of 20 is given, and overall depth is 750 mm. तो effective depth कितना हो जाएगा? ठीक है, so this is 40 mm. So how much will be small d?
710.
710. So this is
410.
410. So now we got. So now to find XU, what is the equation? Just now we had discussed. Yes, equation क्या है XU find out करने के लिए? Anyone?
0.36 FCK B into XU equal to 0.87 FY AST.
So basically we will equate CU equal to PU. So that will give me 0.36 FCK into XU is equal to 0.87 FY into AST. Okay, now substitute the values and give me the value of XU fast. Okay, we have 4 minutes left. 157.54. So which implies XU is 157.54 m. So now we got the value of XU. So next we will find out XU max. Correct? अभी XU max का value बताओ. XU max for M20 and Fe415. For Fe415 कितना है? XU max
48D.
Yes, 0.48D. So this will be how much? 340.8. So we got the value of XU max also. So therefore, compare करो. So here XU is less than XU max. So therefore, it is an under reinforced section. Therefore, it is an under reinforced section. So now we will find out MR. So to find MR is equal to CU into lever arm. So this is given by 0.36 FCK D into XU into lever arm is D minus 0.42 XU. Now give me the value of MR fast. 0.36 FCK 20 है, D कितना है 300 into XU is 157.54 and D is 710 minus 0.42 और XU कितना है again 157.5. So MR is 219.087.
सर वो TU into liver arm रहेगा ना? MR is equal to.
MR find out करने के लिए अभी मैंने बताया ना, MR you can find out by either CU into liver arm or TU into liver arm.
All right, sir.
219 point, let us say 09. Okay, so you can also do MR is equal to liver arm. ठीक है, इसका भी कैलकुलेट करके बता दो MR से, then you will understand. So next, I think we have only 1.5 minutes left. So we got the value of MR. So next is nothing but you have to find out the safe UDL. Okay, safe UDL you can find out. So the fourth step is to find safe UDL. So now we have been given the span of the beam 8 meters, correct? And the load. So now tell me, so bending moment mu is given by wu into L square by 8. Okay, so this W, remember, this is the ultimate load. Okay, so in LSM we are dealing with the ultimate or the factored load. So now you will equate this MR to M. So equate MR to M. So what you will get, moment कितना आया था 219.09 is equal to W is unknown, L कितना है 8. So which implies WU कितना है